Hello there, and welcome to Pure Process, a journey exploring remarkable traditional processes from around the world. In today's episode, we travel to the rural countryside of Poland to observe two historic woodworking crafts. From timber gathered in nearby forests, craftsmen shape durable wooden cartwheels used for agricultural work. From the same material, they also create the ligawka, a long wooden horn whose deep tone carries across villages and open fields. Let us begin. For centuries in rural regions of Poland, the construction of a wooden wheel has traditionally begun in the forest. Within the structure of a traditional wheel, the hub forms the central component, where forces from the spokes and rim converge before transferring to the axle. Because of this role, it is always the part crafted with the greatest care by the wheelwright. The wood most commonly selected is elm, whose naturally interlocking grain structure helps prevent splitting under the heavy compressive forces exerted by the spokes. The process begins with selecting a solid block of elm that contains straight grain and no visible cracks. The wheelwright roughly shapes the block with an axe, removing excess material to produce a cylindrical blank. Using dividers, he carefully marks the center point on both ends and draws concentric circles across the surface. These guide marks ensure that the piece will rotate evenly once mounted on the lathe. The wooden blank is then fitted onto a traditional pole lathe. As the craftsman presses the foot treadle, a rope wrapped around the wood causes the workpiece to spin forward. When the foot rises again, the flexible pole pulls the rope back, rotating the blank in the opposite direction. This alternating motion allows the craftsman to shape the wood while it moves back and forth. While the workpiece rotates, the wheelwright rests a gouge chisel against the tool support and begins removing thin layers of wood. Each controlled pass of the blade gradually reduces the surface. With every rhythm of the treadle and each careful cut, the rough block slowly transforms into a smooth and balanced hub. Over time, the rotating timber takes on the precise circular form required for the center of the wheel. After turning is complete, the craftsman drills a hole through the center of the hub to create the axle bore. He then marks and drills evenly spaced holes around this central opening. These holes will later receive the spokes that connect the hub to the rim. At this stage, the central element, the structural heart of the wooden wheel, begins to take shape. The hub forms the center of the wheel. The rim is the part that meets the ground. It must withstand friction, impact, and the full weight of the vehicle as the wheel moves across uneven terrain. For this reason, The rim must be both strong and slightly flexible in order to absorb constant vibration. To achieve this balance, the wheelwright usually selects straight-grained ash or oak, woods known for their strength and resilience. To create the curved shape required for the rim, the wheelwright begins by selecting straight-grained pieces of ash or oak. These hardwoods are valued for their ability to combine strength with flexibility. Before bending can occur, the timber must first be softened using heat and moisture. The wood pieces are placed inside an underground steam pit and covered with wooden planks. A fire is then lit beneath the chamber, heating water and producing steam that surrounds the timber. Under the influence of heat and moisture, lignin, the natural substance binding the wood fibers together, begins to soften. As this happens, the otherwise rigid timber becomes temporarily flexible. While still hot, the wood is removed quickly from the steam pit and placed onto a curved, bending form. Using hand pressure and wooden pegs, the craftsman forces each piece to follow the exact radius required for the wheel. The timber remains secured in this position until it cools and the shape becomes fixed. After drying, the curved pieces are cut into segments known as felloes. These components will form the outer rim of the wheel. Each segment is carefully trimmed and planed so that it matches the correct circular radius. Openings are then prepared along the inner edge of the felloes to receive the spoke tenons. When these sections are placed together around the spokes, they will eventually create the continuous rim. Between the hub and the rim are the spokes, which transmit forces across the structure of the wheel. These elements must remain strong while supporting heavy loads during movement. For this reason, the spokes are usually made from oak, a hardwood with excellent compressive strength. Rather than cutting them from sawn boards, craftsmen often split them along the natural grain. This method preserves the continuous wood fibers and greatly improves durability. The rough blanks are then secured on a traditional tool known as a shaving horse. Using a draw knife, the craftsman gradually shapes each piece into a balanced spoke. Thin layers of wood are removed with controlled strokes, producing a smooth and slender form. At the inner end, a square tenon is cut so the spoke can fit tightly into the mortise of the hub. The outer end is tapered so that it can later fit into the rim segments. Once the hub and spokes have been prepared, the first stage of assembly begins. The wheelwright carefully measures and marks the positions of the spokes around the hub. Depending on the size of the wheel, it may contain 12, 14, or 16 spokes. The spacing must remain precise, because even small misalignments would cause the wheel to rotate unevenly. Accurate positioning ensures that forces are distributed evenly throughout the structure. After marking the positions, the craftsman drills and refines the mortises in the hub. These holes are not drilled straight outward, but at a slight angle. This design produces what is known as the dish of the wheel. The angled spokes help the wheel resist lateral forces when turning or traveling over rough ground. With the mortises prepared, the spokes can now be driven firmly into the hub. The spokes are driven firmly into the hub using a wooden mallet or a small sledgehammer. Each tenon is shaped slightly larger than the mortise so that it fits tightly when forced into place. As the wood compresses under pressure, friction locks the joints securely. This technique allows the spokes to remain fixed without the use of glue or metal fasteners. When all spokes have been installed, the basic framework of the wheel becomes visible, with the hub at the center and the spokes extending outward. After the hub and spokes have been assembled, the process moves to fitting the wooden rim. This stage is important because the rim must align precisely with the outer ends of the spokes. The rim is not made from a single piece of wood. Instead, it consists of several curved sections known as felloes. Each segment has already been shaped to match the wheel's radius and prepared to receive the spoke ends. Before final assembly, the wheelwright places the felloes loosely around the structure to check their position and overall fit. During assembly, each rim segment is gradually pressed onto the ends of the spokes. Tools such as rim levers or spoke clamps help guide the pieces into position. The felloes are intentionally made slightly shorter than the full circumference of the wheel. As the last sections are forced into place, tension forms around the structure. This compression pulls the wooden components tightly together and strengthens the entire framework of the wheel. Once all felloes have been installed, the rim forms a continuous circle around the spokes. The structure of the wheel now becomes clearly visible. At the center sits the hub, while the spokes extend outward to support the rim. Although the form is complete, one important step remains. To reinforce the wheel and protect the wood, an iron tire must be fitted around the rim. The iron tire is prepared in a charcoal forge, where it is heated until the metal begins to glow. Bellows feed air into the fire, increasing the temperature and allowing the iron to expand. The tire is forged slightly smaller than the wooden rim, so that it will grip tightly once installed. When the metal reaches the correct temperature, the blacksmith lifts it from the forge using long tongs. Working quickly, he lowers the heated ring over the rim before the iron begins to cool. Once the heated iron tire has been positioned around the wooden rim, the metal must now contract in order to secure the structure. Cold water is poured over the glowing band to accelerate the cooling process. As the temperature drops, the iron begins to shrink. This contraction pulls the metal tightly around the rim and clamps the wooden components firmly together. Through this process, the iron tire not only protects the rim from wear, but also reinforces the entire structure of the wheel. With the tire now secured, the wooden wheel gains its final strength. The iron band holds the rim segments under constant compression while preventing the wood from loosening over time. This reinforcement allows the wheel to withstand heavy loads and repeated impacts during everyday use. Wood and iron now function together as a single, durable structure capable of enduring years of agricultural work. After the iron tire has cooled completely, the craftsman performs a final adjustment. Using a hand auger, he carefully refines the axle bore at the center of the hub. This step ensures that the opening remains straight and properly aligned. A smooth and accurate bore allows the wheel to rotate freely once mounted onto the axle. Only after this adjustment is complete can the wheel be considered ready for testing. The finished wheel is mounted onto a traditional plow and taken into the field. As the plow begins to move forward, the wheel makes its first rotations. These first movements confirm the balance of the structure. From timber gathered in the forest, craftsmen have shaped a wooden wheel capable of supporting the daily work of rural life. But wood in this region is not used only for tools. From the same material, another craft emerges that carries sound across fields and villages. From the same forests where timber is gathered for tools, craftsmen also create the ligauka, a long wooden horn with a deep and resonant sound. The making of this instrument traditionally begins during the winter months. At this time of year, the sap inside the tree has retreated, leaving the wood more stable and less likely to crack. Timber cut during winter is also more resistant to insects. These qualities make it well suited for shaping musical instruments that must remain durable over time. To begin, the craftsman climbs a tall pine tree in search of a naturally curved branch. This natural curvature is important for the final form of the ligauka. The horn gradually widens from the mouthpiece toward the bell, creating a shape similar to the horn of an ox. Trying to bend a long, straight piece of timber into this form would be difficult and could lead to warping later. For this reason, a branch that already follows the desired curve is carefully selected. Once a suitable branch has been found, it is cut using a handsaw. The timber is then carried back to the workshop where shaping can begin. The curved branch is placed on a sturdy wooden support block. This support holds the timber steady while the craftsman works along its length. At this stage, the main tool used for shaping is a hand axe. Using controlled strokes, the craftsman removes the bark and trims away knots and irregularities. Gradually, the rough branch begins to take on a more refined form. One end of the timber remains wider to form the bell of the horn. The opposite end narrows to create the mouthpiece. This gradual widening forms the conical shape that allows the instrument to project sound over long distances. After the rough shaping has been completed, the timber is secured firmly on the workbench. The craftsman continues refining the surface using tools such as a draw knife and a hand plane. Thin layers of wood are removed until the body becomes smooth and evenly rounded. During this stage, the natural curve of the horn is also adjusted slightly. At the wider end, the bell is shaped more clearly so that sound can spread effectively when the instrument is played. At this stage, the general form of the legauka has begun to emerge. However, the interior of the instrument must still be hollowed. Because of its long, curved shape, the horn cannot simply be drilled from one end. Instead, the craftsman splits the wooden blank lengthwise into two halves. To do this, he uses a frame saw fitted with a thin blade. The cut must follow the natural curve of the wood, so the two halves will later align perfectly. Once the horn has been divided, the craftsman marks guidelines on the inner surfaces of both halves. These marks indicate the thickness of wood that must remain after hollowing. The walls of the horn are usually left several millimeters thick. This thickness keeps the structure strong while still allowing sound to resonate properly. Using a gouge chisel and a wooden mallet, the craftsman begins removing wood along the marked lines. hollowing process continues gradually along the entire length of the horn. Layer by layer, wood is removed to form the internal passage of the instrument. The bore is not carved as a straight cylinder. Instead, it widens gradually from the mouthpiece toward the bell. This expanding internal shape forms the conical bore that helps project sound. During this stage, the mouthpiece area is not yet fully opened. Once most of the interior has been carved, the craftsman refines the inner surface. A heated iron rod is inserted into the bore of the instrument. The heat burns away rough fibers and smooths the interior. This method is particularly useful near the narrow mouthpiece, where carving tools cannot easily reach. The result is a cleaner inner channel that allows air to move freely through the horn. Before the two halves of the horn can be joined, the craftsman prepares the binding material that will hold them together. Thin strips of tree roots are commonly used for this purpose. These roots are gathered from plants such as pine, spruce, or slender willow. To make them flexible, the roots are placed in boiling water. The heat softens the fibers and allows the strips to bend easily around the curved surface of the horn. Once the root strips have softened, the two halves of the horn are carefully aligned. The craftsman brings the edges together along the original cut line. The fit must be precise so that the instrument remains airtight. The softened root strips are then removed from the water and wrapped tightly around the body of the horn. As the roots dry, they begin to shrink, tightening the bindings and holding the two halves firmly together. These bindings run along the entire length of the instrument. Each band is spaced evenly to maintain pressure across the joint. Beyond holding the structure together, the root bindings also give the legaca its distinctive appearance. This method of fastening reflects traditional techniques that existed long before modern adhesives were available. Through this simple process, the body of the horn becomes secure and stable. After the bindings have set, the craftsman completes the mouthpiece at the narrow end of the horn. The opening must be shaped carefully to allow the player's lips to vibrate against it. Unlike instruments that use reeds, the legaca produces sound through the vibration of the player's lips. Air is forced into the narrow opening and travels through the long internal passage of the horn. As the air moves toward the wider bell, the sound becomes amplified. Before the instrument is tested, the craftsman pours water through the interior of the horn. This removes any remaining wood shavings left from the carving process. The moisture also causes the wood fibers to swell slightly. As the wood expands, the joints tighten and the instrument becomes better sealed. Once the excess water drains away, the legaca is ready to produce its first sound. After the instrument has been completed, the craftsman raises the legaca and places his lips against the mouthpiece. With a controlled breath, air is forced into the long wooden tube. A deep tone soon emerges from the bell of the horn. Because of its length and conical shape, the sound is able to travel across forests and open fields. For generations, this instrument has been used to call villages or signal across long distances. From the trees that grow in the forests of Poland, craftsmen create objects that serve many purposes in daily life. Through knowledge passed down across generations, wood is shaped into tools and instruments that remain both practical and enduring. In the craft of wheelwrighting, every component, from the hub to the spokes and the rim, must be prepared with care and precision. These parts must work together to support weight and endure repeated movement over rough ground. The making of the legałka reflects a similar understanding of natural materials. Craftsmen select curved branches during winter, split the timber, and hollow the interior before joining the pieces again. The body of the horn is secured using natural root bindings rather than modern fasteners. When completed, the instrument carries a deep tone that can be heard across wide distances. For many communities, this sound has long been part of rural tradition. Although these two crafts produce very different objects, they share the same foundation. Both depend on an understanding of wood, careful shaping with hand tools, and experience gained over many years. Each stage requires patience and attention to detail. Through these techniques, simple timber from the forest becomes objects that support work and culture alike. The steady rhythm of traditional tools plays an important role throughout the process. From the motion of the pole lathe to the carving of wood with chisels, every step reflects a method developed over time. Rather than relying on machines, the craftsman works directly with the material. This connection between skill and material allows each piece to be shaped with accuracy and purpose. Today, modern manufacturing has replaced many traditional methods of production, yet crafts such as wheelwrighting and legałka making continue to represent important cultural knowledge. They demonstrate how earlier generations used natural materials to solve practical problems. At the same time, they preserve techniques that remain closely tied to the landscapes where they began. Every wooden wheel turning across a field, and every deep note of the legałka echoing through the countryside reflects this tradition. Wood, fire, steam, and skilled hands combine to create objects that endure across time. These crafts remind us how knowledge, patience, and natural materials come together to shape the tools and sounds of everyday life. Thank you for spending a few quiet minutes with Pure Process. If you enjoy exploring traditional craftsmanship and the processes behind everyday tools, consider subscribing to the channel. Here, we continue discovering how materials, tools, and skilled hands come together to shape the objects of daily life. We look forward to seeing you again in the next episode of Pure Process.